I just started recording. By the way. Any ideas? Thad, what's your ideas? Just going to pick anyone I see in the scroll bar.
No, I was giving you a thumbs up that you were recording.
Oh, yeah. Well, now you
It
just
was going to
volunteered.
make me guess. I would say recursive function, but
That's it. That's the word that I'm looking for. Recursion is the concept of where a function calls itself. Okay? So recursion, right? Let me put this in uppercase. Recursion is when a function calls itself. Okay? And we're going to incorporate recursion. Okay? A lot of these algorithms, as you start to move forward with like merge sort, quick sort, and some of the other sorts we'll get into, searching, a lot of it does require recursion for the thing to call itself, especially when we don't really know how many times we got to split it. Or just recursion is one of those cooler ways of doing it. Okay, so when we do this recursive, we know that we have to do a few things. I'm going to leave the base case off for now, just so that we deal with what we're asking this thing to do, okay? The thing that we're going to ask this thing to do is to take this array. Ultimately, what we saw was this array should be at least, at some point in time, split up into this, right? Into 1, 2. And then those arrays individually should then be split into unique little arrays, right? That's what they had. And that's what we're aiming for. We're aiming to do that. We start with this array, the function runs, it splits it into 2 equal portions, so that's some sort of indication of how we are going to aim to split it. So I have 2 equal portions. I then take each one of these and split them into their own unique arrays, and then we have to do something, right? So I would say at this point in time, if we had to kind of define a base case of when the function should stop running, and we hit this last point here, what could be something that's different between this array and these individual arrays? What's one property that you could tell me that this array holds and that this array holds? The value is different.
Length.
It's the length, right? So length. This has 4 elements. This has 1. So I'm thinking our base case could be something where if the array length is ever less than or equal to 1, then that's our base case, right? If we're going to keep dividing it, when do we stop doing this and actually start doing something? Well, that would tell me that the base case should be if the array.length is less than or equal to 1, then we should return the array. That's what we should do at this point in time. Just return the array. And you'll see later on what returning the array will do, okay? So if we know that that's our base case, and we know now the recursive case says, and here, this is where we're going to get into our recursive case, right? So we are going to say else do this other thing. That's recursion. Do the other thing. So what we need to do in here is to, if I want to, I'm going to walk through the process, right? I had an array. I split it in half, correct? So now I should, for in this recursive case, find the middle index. Find which element would represent maybe the middle, a middle number between these. And so we can do that by doing maybe var middle index is equal to math.floor. And we're going to take the array, take the length, and divide it by 2. Now, why would I use floor here also? Does anyone have an idea of why I would use floor? If I'm dividing this array that is 4 elements, if I divide it by 2, I get back 2, right? I get back a number. Awesome. But what if it was 5? What would I get back?
Get back 0.5.
2. Yeah, so there's going to be times when the array cannot be divided evenly between equal portions. Sometimes the array may have 2 elements and the other array may have 3, right? At any one point in time, they are either going to be equal or one array is going to have 1 less element than the other array, okay? Because if we did have another array, like let's R is equal to 5, 4, 3, 2, 1, well, then the first array would be 5, 4, and then the second array would be 3, 2, 1. Okay? We need to divide the array, and in order to do that, we need a whole number to do that division. And there's a reason, because once I get the number that I'm dividing, I'm going to use an array method to grab elements from the beginning of the array to that index number. And then I'm going to start at 1 after the index number and then grab elements to the end of the array. Okay, so I have this, find the middle index, we have the middle index. Okay, so now what I want to do is use the middle index, right? And split the array into left and right sides. Okay, that's what we want to do. So if we did this, we have 2, so now we can split them into left and right side. So I'm going to say var left is equal to array.slice. Okay, I don't know, has anyone used slice or used on their project at all? Maybe during the carousel or something, you might have been introduced to it. Can anybody kind of, without me doing it, does anybody know what slice does as an array method? Because once again, if you don't know the array method, you may not know to use it here.
I think you specify where you want it to start and then where you want it to end the slice at, and it'll pull that out and put it into a new array.
Correct. That's exactly it. And if you did want to ask that question, like, oh, how do I divide an array or remove specific elements, and somebody mentioned slice, you could just do slice, you know, array, JavaScript. It's going to take you to W3 schools, which is where, once again, I always kind of prefer to go. And I'll say, like, it's a non-mutation method where you could do this, and you don't mutate the original method. You just kind of remove things and store them in another array. So I'm being very selective about what I want here. And if I do fruits.slice 1 to 3, and we just kind of go into the example, we try it. If we did this, I start at the first element, 1, and then I'm going to 1, 2, 3. You have to also understand the positioning of it, right? Because it's like start at 1, and this is 0, 1, and I'm like, all right, and then go 1, 2, 3 elements deep, right? It's a little confusing sometimes when you look at slice because you're used to always doing it based on position. This first is kind of the position, but then this is like starting from the beginning and counting to 1 to go all the way up. And we only have orange and lemon here based on this construct, right? Just a different way of kind of looking at it, okay? And I'll tell you, start optional integer that specifies where to start the selection, and the end, an integer that specifies where the end of the selection, okay? So I'm gonna go back here. We know that we're gonna use slice. I wanna start at 0, and I wanna take it to this middle index, okay? So this should now return, left should be, it should be 4, 3, right? If we split it, left should be equal to that, and var right should be equal to middle index array.length, and that should be 2, 1. We split it, we have equal portions. Now we're ready to kind of go. Now
is there a reason you're using var?
The code snippets that we have var in it, and I remember the last time I used let as the variable, we ran into an issue. So I'm going to use var, make sure it worked, go back and change it to lets, and just confirm that that's not going to mess up the scope. But off the top of my head, I would have defaulted to using lets, but the last time we did, there was that one use case, and I was doing these using vars earlier. So I'm just going to stay with vars. We'll go back and we'll change them to lets in just a little bit. So now I'm going to sort both left and right using merge sort. Okay, so the fact that I'm saying I'm going to use merge sort, well, merge sort is the name of our actual function. So let's do something. I'm going to say var left sorted is equal to merge sort left. What am I doing here? Can anyone kind of explain what's happening there? What am I actually doing here? I'm passing back in something back into merge sort, and that is an example of what?
Recursion.
Recursion, right? This is the example of recursion. We're calling the function again while we're in the function, and we're passing an array to it. We're passing 4 and 3. And so this process would go through the same thing, and ultimately we would wind up with an array that has 4 and then an array that has 3. That's the ultimate goal that's going to achieve with this, okay? I'm going to do var right sorted is equal to merge sort right, okay? So I'm doing the same thing. I'm going to pump this back in, and if we pump it right back in, we're going to see that it would split it, right? Because we have here, it would split it, all right? 2 divided by 2 is 1, then it would take 1, it would create an array that has just 2, another array that just has 1 in it, and then if we did put it right back through the algorithm again, we'd hit that base case and it would stop because the array length at that point in time would be less than or equal to 1, okay? So if we keep doing this process, ultimately we're gonna wind up with an array that has 1 element. The minute that array has 1 element, this base case is done and we return that element, okay? Now we're gonna move on to the actual sorting. Here we go, merge the 2 sorted arrays together. So now we're gonna merge them. Now, we already have this function here called merge. We're gonna use that function. So let's pass our arrays as they exist right now to that function. So I'm gonna say, hey, return whatever merge returns. So I'm gonna say merge. We're gonna say left sorted and right sorted, okay? Ultimately, the first time we do this, right, we would be passing in these elements, right? Or we would be passing in single items, right? We'll see it in just a minute. So I have merge sorted. Awesome. So now what we need to do is just configure the merge algorithm, and then we'll walk through debugging it so we can see. And I want to draw it out. I want to visualize what's happening here so we can kind of wrap our heads around it. So if this takes in 2 arrays, it's going to return a sorted array, right? It's going to return an array that has been sorted. And so we have to figure out kind of how to do this. So I'm going to say var result is equal to an empty array, okay? In the end, this thing will return result. I need to do more with result right now, but just know that result is an empty array, which means at some point in time, we need to push things into that empty array, right? We're gonna like compare things and like push them into this empty array in a sorted fashion so that it's all sorted, right? That's the ultimate goal, okay? So what we wanna do now is to decide or use a looping construct that can determine how many times we need to do this, okay? There's gonna be a point in time where we're gonna have 2 arrays with 2 elements, arrays with like 5 elements and 5 elements, or 4 elements and 5 elements. We don't know. So I'm going to use a while loop to do this. I'm just going to create some space here. I'm going to say while array 1.length is true as long as I have elements, and array 2.length is true. Do this. Okay. Now the fact that I'm saying like make sure that these array lengths are true. The reason why I'm doing that also is because I'm going to be mutating these original arrays. I'm going to be taking things out of them and pushing them into here. So this result array will be the accumulation of me taking something from one array and giving it to the other, thereby decreasing the lengths of these arrays every time I remove something and I put it back in here. Okay, and you're going to see that. So I'm going to say, I'm going to do my comparison now. So compare. If array 1, 0 is less than or equal to array 2, 0. Okay, so now we're going to compare the very first things in the array. If this is less than or equal to that, then we are going to take results. we're going to push an element in there, and we are going to push array1 dot shift. Does anyone know what dot shift does as an array method?
It will add an element at the beginning of the array.
Well, shift will add an element. Well, will shift add an element, or will push add an element?
So shift actually removes the first element from the array.
Correct. So when we were learning about arrays, right? So maybe just a little array lesson here, right? So if we did have our, right? No. So so var array is equal to, oh my God, come on. 1, 2, right? If I do this and I do array.shift, it removes the element from the beginning of the array, right? And do we know how to remove an element from the end of the array? What's the method for that?
Pop.
Yeah, so array.pop would remove the element, and now array now is empty. Okay, so the pop is at the end, shift removes it from the beginning, and it is a mutation method, in that what we've done now is mutated the original array. Array1 now has lost its first element, which means its length is decreased by 1, which follows suit to what we were trying to achieve here, right? So as those arrays are decreased in length, and this while loop is run again and run again, the length of those arrays are going to decrease where there is nothing in the array, and this while condition will no longer be true. Okay, that's our ultimate goal. Now, if it's not that, right? So if that number wasn't less than the other number, then the reverse is true. Like, so then we would result dot push R2 dot shift. We take the other element. That must mean, hey, this element is greater than that other element, so then that other element should be first in line in the array. We're trying to get the numbers in there and do this comparison. If these two, whichever one is less than the other one, push that into the array, and then we can keep track and put things in order doing this. Ultimately, at some point in time, both array1 and array2, one of them at some point in time is not going to have anything left inside of it, right? And if it doesn't have anything left inside of it, then this while loop doesn't run. And then we need to return the results. But I also need to, because there may be an element still left in one of the other arrays, right? If I have an array of 3 and I have an array of 4 because of the division, right? And I put it in here, well, there's still an array element there that needs to make it into result. Otherwise, we've lost an element in our order, right? If I just toss that thing out, that element in that array is still pertinent to what we need to do. So there's a method, an array method, that allows us to concat two arrays. And what I'm going to do is I'm going to take result and concat array 0, which really doesn't have anything now, right? Or not. It could. One of them is not going to have something. The other is going to have a remaining thing. So I'm just kind of hedging my bets. I don't know which array doesn't have or only has the single element left, if possible. So I'm just going to say take result and add these additional arrays to it. That's what the concat does. So concat, okay, concat is an array method that joins arrays together. That's what it does. Okay. Now that we have, what's that? Somebody said something?
Yeah, so I just wanted to know. So it will first concatenate array 1 with array 2 and then the result with the result. Is it like that?
So the concat should take all of these arrays, right? Because the result does have something, right? So result is an array right now, correct? Mm-hmm. So the fact that result has things and it's saying, hey, I want you to also join me with these other arrays. These two other arrays, I want you to take their elements and give them and place them within my array in the order that
Okay.
they existed here. So now remember, one of these arrays will have one last thing left, right? Because if we went through this and we removed everything and there's just one array left, array 2 has one element, right? And if we only have one element left, then we're really joining an empty array, which is nothing. Array 1 would have nothing, and then array 2 would have the one last element, and we just concatenate that. Okay, and you're going to see it when we get to when we get into debugger and we start to kind of go through it. You'll see this pattern happen, and then I want to kind of draw it out and visualize it, so you'll see what's happening.
Yeah.
Okay.
So are you getting down to where one array has nothing left and the other one has something, and that's how you stop the function?
Correct. Yeah, that's it. So this really, what would we call this? If we were like playing the game of recursion, because this while loop it's not a recursive function. Like recursion means a function that calls itself, right? We know that. So when you say recursion, you are stating that it is a function that calls itself. That's the concept of recursion. Recursion is a form of looping, and this is also a form of looping. All looping constructs need a base case, right? So in essence, this condition right here becomes our base case to stop the while loop. It's a condition. As long as that condition is true, the while loop keeps going until once that condition is false, the while loop stops, right? So all looping constructs need some sort of condition to tell them when to stop. And if we just use the concept of like base case and recursive case, which are very specific to functions, we can kind of apply that concept here. Well, this would be kind of the base case would be when one of these things doesn't have a length. The recursive case is that both of them have a length, right? Conceptually, we can translate what's happening in the world of recursion in those concepts and apply them here. So the minute one of these arrays does not have a length because we've taken everything out of that array, this while loop doesn't run. But what that does mean is there's probably an element in one of these arrays. I don't know which one, but there's that last element that didn't get compared because we had taken everything out. And so now we have to deal with that last remaining element. And by doing that, I don't know which one of these arrays, and we can even say that, we won't know which of the arrays contains that last single element. And since we don't know, we need to concatenate. And based on that, we join all the arrays, one of which is empty. Nothing there. We don't know if it's array 1 or array 2. I have no idea. So I'm just like, grab them both. Whichever one has something, that will get added. If it's an empty array, it's nothing. Nothing gets added. It's an empty array, right? If it does have something, then we'll see it. And we will see this in the process. Once we kind of hit debugger and we kind of go through this, we'll see it. So I'm just going to save this. And then I want to kind of run it. Let's make sure that the thing works. Right, I went through all the code. I added a bunch of stuff. I'm going to just kind of collapse these just so that we can run the function. So I have merge sort, I have an array, and here I'm going to say, hey, let's run merge sort, and let's pass in our array, right? That's our array. Maybe I'll use array here so that I can distinguish the naming convention, right? This is a parameter, and this array here is an argument that we're passing into the function. This is a placeholder. This is an actual value, right? So I'm going to console log, and let's just see if this does kind of what we wanted it to do, right? So I'm going to get rid of this. I'm going to save it. Let's run it. And I get an unexpected token on line 32 right here. Merge. So I'm going to go here. Did I not close it? I think I closed it, right? Oh, no, it's merge right here, right? Merge results. I'm going to do that with that. I don't see where the error is. Can anyone spot it? It's just an unexpected token there. We have array 1, array 2.
You're not actually defining it as a function, Joe. You're just
Oh,
calling it.
snap. You know what? Yeah. You know what my brain was like thinking objects. You know, when you create an object, you don't need the function keyword when you're creating a method inside of an object, and that's kind of where my brain went. So we have the 2. Cool. Awesome. I'm going to get out of here. Let us go back to the console. I'll clear out the console. I'll save it. Console, right? We'll run it one more time. So I want to save this point. Run it. And boom, now we have a sorted array, correct? Our array looks sorted. Everything looks good. What I want to do now is break this down into what's actually happening within something like the call stack, which is what we had seen when we had covered recursion. So in order to do that, I need to add a debugger here. I need to put some sort of debugger that stops the code from running so we can examine the process. So what I'm going to do is I'm going to add a debugger here. I'm going to add it on line 18. Actually, I'm going to add it not on line 18. I want to do line 18. Or do I want to do it here? I think I'm going to do it here before we hit the recursive functions. Okay. Now I'm going to go into settings on my pen, and I'm just going to stop it from automatically executing. Like, I want to tell it when I want this thing to run. If I add something in the JavaScript, it immediately runs, and I'm kind of tired of it running. So I went into the settings, I went to behavior, and I unchecked auto update preview. I'm going to close it. Now I'll have this run button. Okay. The code only runs when I tell it to run. That's what I want it to do. Okay. And of course, I want to run it. So I'm going to run it. Did not run. Save. Run. There we go. Now we're in debugger mode. Okay. So if we look here at debugger, right? Let me see if I can strip this off. I must never undock it. So I'm going to put it over here. We'll put this over here. So we can maybe see these two side by side. Here's our debugger, right? If I take a look at the debugger, let me just kind of come out just a little bit here. All right. Here's the debugger. Now, when we ran this thing the first time, I'm going to go up here because the variables are being defined now. Here's the array. That was passed in the very first time. We did the comparison. Hey, is array.length less than or equal to 1? Nope, because array still has stuff. So we jump into the else. The else breaks down and says, oh, the middle index is 2. It's 4 elements divided by 2. We get 2. Cool. An array has 4 elements. Awesome. Now let's get the left side. Here's the left. The left contains 4 and 3. The right will contain 2 elements, 2 and 1. Awesome. We knew that that was going to happen. Now I stopped it before we hit left sorted. Now I'm doing that. What I want to do is this. You see the call stack? Did anyone, when we had done recursion, does anyone remember what the call stack is being used for? What is the call stack?
It's like the order in which things were done. It's like
Yeah.
kind of setting them aside for the moment, and then when it goes through, it'll go from top down.
Exactly. So when we demonstrated recursion, like reversing a string, we saw that those recursive functions, those function calls that we were calling recursively, were being stacked on top of each other. Remember that JavaScript can process one thing at a time, right? It's like single-threaded. It only knows how to do one thing at a single point in time, and once it's done, it releases and goes to the next thing. It cannot process more than one thing. Even like a hyper-threaded CPU really only processes one thing at a time. Okay, it can't really process multiple things. So right now, if I look inside of merge, this particular instance of merge sort, I see I have an array, and I have left, and I have right. Awesome. I'm going to step in to the function now. That's where this step into the next function call goes. And I'm going to, the minute I click on this, it's going to take me to left sorted, and I see merge sort left. Awesome. It's going to call the function. Now watch the call stack. The call stack now has 2 merge sorts in there. And I can examine both instances of those function calls. So if I go back to the first one, let's take a look at the first one. This was the original one. look, the array is 4 elements, just as we expected, 4, 3, 2, 1. Left was 4 and 3, right was 2 and 1, awesome. I'm going to take a look at the other function call and look at it. That function call only has the left version of that array. It only has 4 and 3. And since we haven't gone through the rest of these variables yet, they're all undefined because we haven't actually kind of hit them and loaded them into the global scope, or this function scope here, because this scope here is scope to this function, okay? So if we walk through it, I'm like, all right, cool, let's go through it. This obviously didn't match, right? This wasn't a true condition because it's false, so awesome. So I'm gonna say, all right, we're gonna split the thing again, and if we split it, the middle index is 1, as we expected, awesome. Now we're gonna slice, and if we slice, the left should be 4, the right should be, let me see, the right should be 3, right? I was looking for the right. Awesome. Now we hit this again. That triggered our last recursion. We haven't even touched this yet. We haven't hit right sorted yet. That hasn't even been touched yet. We're still in like this recursive thing happening. What happens when we do this? Can anybody walk me through what would happen? If I click on this, what are we going to add to the call stack? What would we be adding to the call stack at this point in time? So no volunteers.
Wouldn't it be right sorted?
So right here, you think right sorted?
Well, I think after that, because it's only.
So what happens when I click on this, Jeremy? When I click on this down arrow to execute that, what goes inside of the call stack?
The length will be less than or equal to 1, so it should just return the array and go on to right sorted.
Okay. So let's test that theory out. So are you saying that nothing would be added to the call stack at that point in time, the minute I click next?
Well, it should add the 4 and the 1 like what you just did. Right?
Okay.
So
So I'm going to be adding another merge sort function, right? Would you say that?
I would say that yes.
Okay. That's all I'm looking for, right? So let's watch. Boink. Look, another merge sort function. Right? And if I click on it, once again, we only passed in the number 4 this time. We have not even gotten to the right sorted yet. We have to go through this segment of all of these little subloops for this, because this is happening recursively until this thing, till this kind of thread ends, we will never hit right sorted. We're stuck in resolving whatever this is, and this is recursive. So until that fixes itself or returns something, will we ever get to right sorted variable? Right sorted variable doesn't even exist in our parent scope here. Okay? Right sorted is still undefined here. Okay? Right sorted is undefined in the second function. We haven't gone through this. So now let's go through this. I'm going to do what Jeremy had said. If I go through this, the array length is less than or equal to 1. So we stop there. Okay? We don't do anything here anymore. And we return the array, which means this function, this one, will be removed from the call stack. Now watch. Removing it, it's going to return the array. The minute it returns in the array, this function will be removed from our call stack. Bloop. It's removed from the call stack. Okay? So it left. Now we're in this function, that other sub-function, because it's like, all right, so the thing that I ran returned something, cool. So now I can start playing with right? And right should contain the number 3, one single element, and I'm going to go into it. If we do this, it's going to put another function here in the call stack, and it did. It put another merge sort function. Now this element is one element. We know that this is going to be true, so that ends it. It's going to return the array. This is going to disappear once we return it, and now I'm in the other function, the second function that we actually called, right? This was the parent function. We then passed in 4 and 3, and we passed it into this merge sort. And so left and right now, here, right? Left and right, left is 4, right is 3. We're actually passing in 2 single elements, are we not? Is this being passed 2 single arrays that have 1 element?
Right.
Right? Left sorted is 1 element. Right sorted is 1 element. We're passing it in to this function. And if we do, it will sort it and return back a sorted array. I didn't put a debugger in the merge function, so we're not going to see that happening, the internals of that. But I'm going to just hit enter. It's taking, oh, it actually is. It's going to take us right in because we're in here. So I'm going to say, all right, cool. Our array now is, our array 1 has that. Our array 2 doesn't have anything. Actually, it's calling just the array 4. Didn't pass in anything. Right sorted didn't have anything just yet. We run it. I get out of this. Let me get out of that too. Oink. And now we're back here. Okay. Once again, here's the sorted. We ran it. I'm going to do it one more time. Let's see what we get. Now I'm back in the parent function. The parent function now has to deal with 2 and 1. Okay? So we already have this will ultimately at some point in time be sorted to 3 and 4. We don't see it yet. I'm going to go into merge sort right. And merge sort, we're passing in there. Okay. We're taking 2 and 1 now. Awesome. We're going to go in. We're going to slice it. We're going to slice it. We're hitting debugger mode. Bloink. And now I'm doing left, and left should be 2. But we have to rerun the function. You see how we're stacking these up now? The same like we did before. This was the original function. This is that sub function that contained 2 and 1. And now this thing here is going to contain the single element. And it's going to return back an array. We push back the array. It removes it from the call stack. We get to right now. Right is going to have 1 element. So that's going to return the array, pop it out, and then we call merge sort. Merge here. Now watch, when I do merge, it should be added to the call stack. Here's merge. It's been added to the call stack because this is the sequence of events that's happening. Now this array contains 2 and 1, right? And so now it's going to walk through the process of sorting it. So it's like, all right, well, array 1 has a length and array 2 has a length. Cool. Going to get out of this window. If array length is less than, and it is, correct? Array 1, 0 is less. I'm going to go into it. And it pushes array 2. So let's take a look. See results right now. Array's result has the number 1 in it because it was array 1 was the number 2 and array 2 was the number 1. So we went into the else statement, right? Now we ripped out of array 2 the numbers. See how array 2 doesn't have anything anymore? It's been stripped of its number because we shifted it out. We mutated it. It's been taken out of the array. So now this while condition won't be true anymore, right? Because only array 1 has a value, but array 2 does not have anything. So we'll go into it. The array should execute to false. We should get to the end of this where it concatenates results, which contains 1 element, and array 0, which contains, array 1 contains 1 element, but array 2 contains nothing. But once again, we didn't know where that was going to happen, so we just need to concatenate. So I'm just going to go next, get out of this execution. I'm going to do the concatenation right now. Now we're doing the concatenation. I'm going to do it, and it should have returned back this function. Now we're into, I'm going to finish it. All right, so what do we got? I'm still going to return this now. We're in merge sort now. The original merge sort now has finally resolved these 2 sub-arrays. So now we have 2 arrays that ultimately will be 3 and 4 and 2 and 1. We don't see it yet, but they are going to be there. And we're going to pass that in here. So I'm going to go in here, and I'm going to do it. Okay. I think it's still array 4. All right. Go here. array 0 is less than or equal to array 2, 0, and they're doing the comparison of 1 and 4. Okay? So it's not, so it pushes 1 in to the array. Look, 1 is in here, and we stripped 1 from the second array. Awesome. It's going to do the comparison again because it's still true. 4 is not greater than 2. That condition is false, so we're going to do the else. We're going to strip 2 out, push it into the result array, and now we only have 4 still stuck in array 1. Okay. When we run this again, this while condition won't run, and we go straight to do the concatenation. Okay, so now I'm going to concatenate to do this, and now what we will see is this now is going to return back a sorted array. So we're back in merge sort, right? So let's see what happens here. We have our original array, our left sorted, middle index, waiting for this to be updated. Let's see. And then it returns back console log. Like, should have console logged the sorted array. Except for this, I think maybe because of my debugger, it stripped out the number 3. I thought that was kind of odd that it had stripped out the number 3 earlier. I think maybe something with the debugger caused that, because what we saw earlier, if I just going to add this back to the bottom of this, if I remove the debugger, this thing did return. Did it not? Let me see. Yeah, it did return 3. I think something with the debugger caused it to like strip out the number 3. I'm not really sure. I've never seen that happen before, that it had removed the number 3. But something with the debugger put a little blip in it. I'm not really sure what that blip was. But we can see that process happening, right? What was happening with the recursion and what we were trying to achieve here with merge sort and its little helper function. Just know that the helper function was meant to do just the comparison of whatever arrays and pass that back. And it's up to merge sort to do the recursion, right? So this is where we run the recursion. Here is where the recursion is executed, okay? And once it's executed, this thread right here needs to return an array at some point in time before whatever function called it can ever touch right sorted. Right sorted will never get touched until this thing returns an array. So this thread, this process needs to be executed in that fashion, okay? I know it's a lot, right? To think this through, to write it, that's a hard ask. You know, you still have bubble sort under your belts and to kind of work through bubble sort. And then to be thrown this kind of algorithm here, which just seems like it's a bit more complicated than bubble sort, in the fact that we have this helper function doing something. We're running through this execution here, and it's like, what is happening? You know? What are your thoughts? Any thoughts on the sorting algorithm, merge sort? Or is it just like, my brain's mush right now? My brain's mush?
Yeah.
Okay.
So I'm having trouble understanding where does this information go? Right. I think about, we started with an array of 4 numbers.
Yep.
We get to line 23. Now we're down to an array of 2 numbers.
Correct.
Then we run through it again and we're down to 1. Like, what happened to all the other 3 numbers? Like, where did they go? And then they just like magically reappear when we're in the next function.
What happens is they are in the call stack within the execution of the other function. The functions themselves are kind of keeping track of everything. So let me just see if I can quickly do this, because I know I always kind of run over. So I just wanted to see if I can do this. So what we have here is, I'm going to put here the call stack. Okay. Call stack is where we're going to store the current execution at that moment, right? And so when we load up our function, the first one that we're going to see is merge sort, right? Merge sort is the first thing that runs when we're running our function, right? And so I'm going to go over here and I'm going to say, all right, you know, this function merge sort runs, okay, and we give it a single array here, right? And then it's going to do something. And there is some context here which with this function runs. This is the function context right inside this box, okay? We also have some global variables, right? Because we did load functions, or we global variables, right? Or global declarations. And in here we had things like, hey, well, we created merge sort. So I don't know why that just happened. Merge sort exists as a function for us to call. We also have merge as a function to call. We have these two things that are waiting for us to call them, as well as the array, right? Because I did create an array, you know, an array, and that was equal to whatever numbers I had, right? So inside of merge sort, we did a few things, right? So if I would just went, oh man, let me do this. Annotate, another annotation tool. I wanted to like erase what I just did behind here. Yeah, all right. So if we take a look here at this function, right, we have a bunch of stuff that we define. We're running this if condition here, right? So if I go back here and I was just like, hey, is the if condition true, right? Let me see if I can go back to here. It's not really working as well as I want. All right. If I go back here and I say, you know, is that if condition true? Oh, it stopped annotating. I think, stop the annotation. Yeah, I lost a little annotation tool. Yeah, without my annotation tool, I cannot annotate. Annotate, here we go. Okay, so just want to stop the annotation. Bring this back up. And now annotate. All right, sweet. So in here, it's going to go right here. In here, we had that first if condition, and that was false, right? The first time this ran, that was false. Okay. Then we got that middle index. That middle index was equal to 2 on the first time that it ran. Then we ran left was equal to 4 and 3. This is the first time. And then right was equal to 2 and 1. And then we ran L sorted, right? So I'm just going to put it left sorted. And left sorted called merge sort. That's what it called. And it passed in the array 4 and 3. Right? Now we're in another function call. And let me do this. Undo that. I'm going to change the color to be maybe blue. Now we're in another function called merge sort. Okay? And the merge sort has its own context. I'm running out of space here. We have to like do something in here, and the ultimate, this merge sort is going to take in those two numbers, right? So now this if condition is once again false. The middle index is now 1, right? Because we're splitting it. Left is equal to 4, right? Right is equal to 3. And then we're calling left sorted again, right? So now I'm like, hey, left sorted is equal to merge sort. And then I'm passing in 4. Okay? Now we're calling this again, so I would have to like change the color.
So what you're saying is that when we go through the function next time, it is not replacing what we did before?
Nope. It's all still in this, in the global scope. It's in this process here is function scope. Everything that happens inside this function needs to complete before the parent function, before this function can do anything. It's kind of waiting. And that's why they were getting loaded into the call stack one at a time. The fact that they were getting loaded into the call stack was the reason why we were waiting for this function to complete. That's why it got loaded into the call stack. We're waiting for it to complete. And then any other sub-function calls, this one to complete, which is going to be another one nested inside of this one, that only when this finishes can this continue doing what it needs to do. And that's when it would go to right sorted. It would have moved on to the right sorted and doubled up on the process. We would have called another function for right sort, passed in 2 and 1. Ultimately, we would have had to pass in just the value 2. We'd have to do this all again till left sorted was sorted with 3 and 4. Right sorted was sorted with 1 and 2. And then we call merge sort a final time to do the sorting of the 2 sorted arrays. It's pretty crazy. I think what we're gonna be doing sorting again on Thursday. And what I'm gonna do next time, now that I've kind of introduced this, what I want to do the next time we do sorting as the morning exercise, I want to actually draw it out, have a clear visual, and walk through the process. Walk through merge sort one more time so we can all kind of understand truly what's happening with what recursion is doing and adding things into the call stack. Okay? I know it's a lot. We just kind of wrote some code. You're like, all right, we ran it through debugger. You saw the process. But even then still, there's still going to be all these questions. And without kind of like seeing this thing done to fruition, where we can like walk through and see what gets returned and see what gets returned, it's still going to be a bit difficult to comprehend. I comprehend it like this, drawing it out, seeing it. I was working on my whiteboard today, and I drew a nice, beautiful picture of it, all done. Really stuck home with what's happening. Even though I knew what was happening, seeing these things clearly in front of me made sense. But I needed to make sure you were able to walk away with a code, the code for merge sort. And I didn't want to just have it there without walking through the code, what we were trying to achieve, and then draw it. So next time I'm going to start with drawing out merge sort so we can kind of at least do a review of this. Okay? But if you do have questions, you can always reach out to me directly. You can DM me if you have more questions about this. Just DM me. I'll try to get back to you. You know, maybe we can jump on sometime and discuss it if you have a question, and you know, we have time together, you know, during lunch or something. If you have a question, just feel free to reach out to me.
I have a question, Joe. Kind
Sure.
of off subject, kind of not.
Yeah.
When you teach in like in your home like classrooms, is it like you do more stuff on a everything on a whiteboard?
I do a lot of stuff. I would have I would have coded it out, but I would have also been writing the algorithms like, hey, we're going to use .slice. Let me put that up here as an array method. I'm going to be using, you know, I forgot what the other, concat. I'm going to be using this. We're going to do math.floor. I'm like breaking things down. This kind of whiteboard isn't the same that I'm used to. And I can't, when I write like this, I just feel like I'm writing super sloppy, and it's not.
I only ask because I feel like if I was in a classroom with you and you were breaking this down, I would probably understand it a lot more.
Yeah. Once again, it's the medium. So remote is great. And we have this tool that allows us to get into breakout rooms, which is something like really awesome. We do have the ability to draw things out. It's just the tools that we have to do it. I would just need more improved tools to be really meticulous with when I'm drawing it. It's still kind of a weird thing for me to use a tablet to draw. I don't really draw with tablets. I draw with a whiteboard. But the next time I'm going to have it nicely done, and then we can walk through the process. I'm going to make sure the next time I draw this out, we have the full screen and everything's there, and we can do it. Cool? Come back at 11:10. Sweet. All right. So this is what we'll do now. Why don't we take a break? It's 11:12. So why don't we come back at say 11:12, or say 11:15. How about that? Take the extra 3 minutes. Back at 11:15. If you do have questions and you want to discuss this, just Slack me and I'll stay on and chat. Sweet. Stop sharing.